Hello everybody, welcome back to another episode of Infinity Evolved. My name is Brink. Today we're going to be working in this area, the reactor. There are some precautionary measures we have to take with the reactor, make sure it doesn't overheat. Now we're still running uranium type of, oh by the way I took the lever off, put pressure plates just so I can access both sides and keep that door closed. In case it blows up even while I'm in here, it won't damage anything else. So what I'm thinking is, setting some precautionary measures for the reactor. Even though it's uranium at the moment, it's not going to blow up the way it's set up. These overclock heat vents never heat up or dry out or deteriorate if it's in this setup, because it doesn't heat up enough. This can handle a lot more than just one uranium rod next to each other. So yeah, this system will never explode the way it's set up. But we want to move up to a different caliber of reactor soon. And maybe in this episode, I don't know if we have enough time to finish it today. But what I'd like to do is set it up and prepare for the future reactor, which will be a MOX type of fuel. And so I'm thinking, let's put a temperature gauge somewhere here where we can see if we need to cut off the power and shut it off with the lever. It'll be a different kind of turning on and off switch other than a lever. It'll be a remote system. So the same system that I have out here, which is on this block here, this reactor sensor location card is what I'm going to be using to monitor that reactor. That sensor kit can do the same work. So let's get to it. Let's get to work here. I did a little bit of research and I found that we're going to use that remote sensor kit if I can find it. Let's see. Where did I put it? Oh, my technology bag. Here it goes. Where are you? Here we go. So we'll feed this into a different kind of block. It's called a remote thermal monitor. Okay, so we need a frequency transmitter. I got an extra, a basic. We'll have to make this, whatever this is. So it's lead plates around an advanced circuit with a redstone. And let's see, advanced circuit. Lead plates, we got plenty. So a red, I believe, was on the bottom. And this around. There we go. And then some iron plates, basic, and a frequency transmitter. So iron plates, and let's see if we can do this. Something like this, I believe. No. Basic. And do we have? Yes, we do. Okay. And there's our remote thermal monitor. Now, it'll receive the message that we're at the temperature that it needs to shut off, but we haven't told it, we haven't explained how we're going to send the signal. Now, the lever acts just like a redstone signal. That's all it is. So we can just activate a redstone signal to it with a wireless transmitter. That'll send a redstone signal. What kind of wireless systems do we have here? This I'm familiar with. I've used this in Unleashed. We could probably do this if it's not too overbearing. It looks similar to, yeah, it's exactly the same as it was before. Alright, let me build one set of these. Alright, so this goes here, redstone, and the plate underneath as a base. So there we are. And we can go ahead and see if we can connect. Where we're going to place it though, I'm not sure yet. But let's go ahead and activate this. The sensor has got to be affected here. So we're identifying which reactor we're talking about, and my sensor is turned into a card. And the card will fit into the remote thermal monitor. The issue though is that we have to power this thermal monitor. And from what I understand, Nuclear Control mod works hand in hand with IC2 mod. So it's probably going to be EU that this is going to use. So let's lay down our remote thermal monitor. We'll place it here. And right now it's set to 500 degrees. In other words, If the reactor goes above 500 degrees, put out a redstone signal. Now, we can actually look at this. We would probably be able to test this if we have any redstone. Oh, I do. Great. Let's see. In this bag. So, right there, it would turn on if it saw the reactor has more than 500 degrees. Actually, we have to place the sensor card in there first. And now it's linked to our reactor. Now it's not putting out 500 degrees because our reactor is nowhere near that. So what we can do, let's go ahead and lower this and give it a couple of degrees. If it goes above 3 degrees, let's turn this redstone on. Let's go ahead and try that. We're going to heat up the reactor. You can see that my temperature right now is 0. The setup for this reactor, this pattern that I've set, is pretty accurate, pretty stable is what I meant. So let's heat it up. What we can do is take out a few of these, and I didn't really want the other fuel rods to come in. So let's shut this off and pull these guys out. Actually, I need to get my hazmat suit real quick. Oh, it might heat up too much, but let's turn this off real quick. Let's grab the ones that came in uninvited and put these back here. Okay, let's take a look now. So these heat vents don't seem to have taken any heat. Let's just take a quick look. No, it's still at 0. Good. So let's go ahead and turn it on. And we'll leave the room. And take a look at the monitor. Well, let's go downstairs and see if this turns on. If it goes above 3 degrees, it should turn on. I should have put 6 degrees. That would have been more interesting. 6 degrees of, let's see. These heat vents are holding up just fine. Maybe we can do this, and that'll heat it up even faster. Let's see. Let's give it a gander over here. Yep, it's up. It went up. It went up too much. It went up too fast. I don't want to destroy any heat vents here, but let's do that. And now, with the temperature, oh, it went back down again because I turned it off and the heat vents reinitialized. So what we can do, let's do the same pattern again and go downstairs. And this time we'll wait downstairs just a couple of seconds, and we should see that the red turns on when it passes 3 degrees. Oh, that... I'm so beyond where I need to be right now. I think I'm going too fast. Let's just ensure this. First of all, before we do any of this, as I was saying before I go downstairs, we need to power it. So if we run this reactor output wire directly into the thermal monitor, then whenever the reactor shuts off or turns off or anything, this thermal monitor will drain its buffer power. We don't want that. We want a separate power system feeding the thermal monitor. So we can use this, let's see, we can take this wrench and grab this extra MFE right here. Let's replace some HV wire here. Now, this MFSU, we're going to have a lot of them, but this MFSU is good enough to power all of our machines here. So we'll just borrow this MFE momentatiously. That's a word I made up. We'll point it into the thermal monitor, and now this has power. Now this can read if this ever goes up above 3 degrees. Okay? So let's go upstairs. And 0 again. Let's turn on the reactor and take off a couple of heat vents. This time should work because now we have power in the thermal monitor. So as soon as this goes up above 3 degrees, we should see this redstone turn on. All right, and there we have our redstone signal. So let's turn this back off. And it's gone up to 12. It's going up quick. Let's turn this off real quick. Hopefully we haven't lost any. But let's replace these. Turn this back on. Oops. That's good. Everything in order. Yeah. Let's turn it back on. We need that power to run our thermal monitor. But yeah, we're at 0 again. Sorry I'm going so fast, but this episode will go long if I don't get to work. So I'm going to try to blast through this. Now, we need more redstone. And I think what I'm going to do is, now that we know that it'll turn on when there's problems, when there's an issue, when there's danger, it turns on. We need it to turn off our reactor, so we need the opposite. So I'm going to pick a NOT gate, and I do have one in storage here. Oh, I moved this up. It might be in here. Here's a NOT gate. Excellent. So let's see. We'll face it this way. No, we'll face it... actually, we can get rid of this. Let's face it this way. So in is into the machine, and there's 3 outs, and we can put this like this. We can get rid of that one, actually. And then we need a transmitter. Now, there's a bug with this transmitter receiver that you have to put the transmitter and set the channel first before you lay down the connection to it. So there it's on. So if there is, well, let's see. We want to go down. I want the thermal monitor to consider it dangerous if our reactor ever goes up above 7,570, and 10 doesn't work here for some reason. I wanted 75, but well, let's see. Let's go up a little bit. I'm going to go up to 7550 and just leave it there, and I'll do the rest later because this is taking forever. 7550. If it goes above 7550, then turn this off. Turn the reactor off. You see, this is on right now. It's always on because it's less than 7550. That is a bit complicated to understand, I know. All right, so we need to lay down our receiver on this side. So it'll go here. And it needs to be set to 200. That's the channel. And there it's receiving the signal. So now the reactor is kept on because of that live signal. You see? If it wasn't for that live signal, it shuts off. It turned off, you see? But the thermal monitor downstairs is telling it, turn on, there's no danger. It's less than 0. I mean, it's less than 7550. So we don't need this lever anymore. But maybe I'll just leave it here. In case of any emergency, I'll just leave it there. I can grab it. If I get to an urgent state where I need to find it, I'll just look through chests. Well, at any rate, that is it for our thermal monitor. This is a working system. This MFE will store power for a very long time. This uses very little power right here, this guy. And it has a little bit of a buffer, but we're not depending on that. So this system is working. Let's move on to something else. I just came back from checking the time on the video, and it seems like we have a little bit of time left, so let's get to work. We have some more things we can do. And what we're going to do is go ahead and step up our reactor to a high-tier MOX reactor. Now, it's not the highest tier there is, but it is a high tier. Let's put it that way. All right, so what we're going to do, let's go, instead of using this thermal centrifuge here, with our limited power, we're only generating 135 EU per tick. And remember that our mass fab production up here is still working. And by the way, one thing I wanted to mention, I think I'm going to opt to remove these panels and have the wires revealed this way. And then I'll back it up with some backer board so we don't see the ocean from the back there. Let's go back here. What I'm going to do is cover this area up like this. And I don't know if this is the right color. Maybe I'll pick a different color. But some panel, some cover is what I'm talking about to put back here. And it looks like I'm going to have to stretch this wire outward. So let's see if we have some HV cable here. Here we go. 1, 2. That should be enough. And we'll break this to go out a bit. 1, 2. And we'll replace that. Okay, so let's cover this. And let's see how this looks from the other side. I can go for this. I think I like it. Let me know what you guys think. If you have another idea, maybe some lights in the back instead, some anti-blocks. I don't know. But I do like the way this is coming out. I really do. And maybe we'll continue the theme around. It's sort of a modern feel, if you will. So yeah, this is producing a lot. The scrap boxes are backed up, so that's awesome because these guys turn off, as you can see. When these back up so much, they're not operating, they're not chewing up energy. So that's good. And I prefer to have always scrap boxes in here because that's a little bit of help with the production of UU matter. And by the way, I've emptied out the UU matter that we had in here into a tank. Let me see, I can show you real quick. I really wanted to get to the other work, but let's see. We have 5,700 so far, and in here we have 1,000, so about 7,000 we have total, and we're getting there. So when we get to 13,000, that's the magic number, guys. Oh yeah. So instead of using the thermal centrifuge, I'm not generating enough power in this area, so I'm going to instead work at our starter base over here. And what I'm going to do is grab the depleted uranium rods that we have, the ones that are used up from what we've used the reactor with. And let's get our hazmat suit on before I touch these because they have something called cooties and we don't want the cooties. So we should have plenty enough for what we want to do. I'm just going to empty them out. Let's see if we can put them all in our inventory. It doesn't matter if I do more than I need. But this will get started. It's going to take a real long time to heat up. So I'm just going to pop these guys in here. And now I'll empty this out little by little. Let's put this back. Awesome. All right, so what we're going to do. I have these component heat vents. And these were things that I've built when I was trying out different designs for the reactor that we have now. That didn't work out, so I never used them. I just used heat vents and the fuel rods. That's all I have there. So I'm glad I made these because we're going to need it for what we're going to use in our new design. And so, but the problem is that I need a lot more. I need about 16 more than we have here. So I've set it up so that we can go through this real quick for the 16. We need to build these heat vents using motors, plates, and iron bars. And there they are. And now they don't stack, so I got to go one by one and fill these in. All right, and there it is. So we have our total 26 component heat vents. I think it's 26 that it was. No matter. We're going to shut off the reactor for a little while. So let's get our lever out. And hopefully this lever can turn it off, even though the thing downstairs is keeping it on. Ooh. So we're going to have to switch this for a little while because this lever has no effect, actually. So that being the case, let's toss the lever back into our tech bag. Smack that in there. And we'll just change the channel temporarily, or momentatiously as I like to call it, just by 1 degree. So that it shuts off. Good. Now I'm going to empty all of this out. And here's the issue. You know what? Instead of emptying it all out, what I'll do, let's shut this off. What I'll do is just replace where the component heat vents should go. Okay, so I think I've emptied it out as far as I need it, and apparently I have 2 extras. Well, if I'm wrong and I'm missing something, I'll just grab it from here. Let's just leave these in here. These are things we won't need since we're using something else. Now I'll empty these out also because we need to make room for some other craft that I have ready back at the starter base. And now the second thing we want to do, which is in this crafting grid, here we go. More of the same heat vents, but this time this gets used as a recipe. That's a lot of heat vents for a new ingredient, which is this, the advanced heat vent. And we want a load of these. This will take me too long a time to show you. And we got the space for the last one. Awesome. So we'll take this back. And now this fills in just about all of what's left over. So these go on the upper edge here. In other words, what we're doing, we're leaving 2 spaces on each one of these 4 quadrants. And I'll fill these all in. Okay, so all 4 quadrants are filled, and now we have a couple leftovers. This one goes here, and this one goes up here. And then a fuel rod will go in here. Now the kind of fuel rods we'll be using are dual rods, dual MOX rods. Or dual MOX Fuel rods, I guess is what it's called. But this design, I'm not sure whose it is, but this is a very popular design that a lot of people use for dual MOX Fuel rods. And so I don't know who to give credit to. If you know, let me know. All right, now we need to go back to the base and continue in making or processing those depleted fuel rods. And we have a long way to go. This is still the first batch, so I'll bring you back once we get more of these tiny piles of plutonium. That's what we're generating with this. Each one of these makes another tiny pile of plutonium along with some uranium-238. Our plutonium has just finished a few seconds ago, and so we have all these little tiny piles. Let's grab them all like that and come over here to craft them. We'll just put them all into one crafting grid. You know, it might have been easier for me to use the inventory slot down here and just go zip on one stroke and then have it fill automatically on its own. But there we go. So now we take this with, I think it's straight down like that. And we need 6 of these. 1, 2, 3, 4, 5, 6. I think this is the right shape. If not, then it's horizontal. Easy enough to change though. So let's give it a try and see. Oops. And there we go. So it is different. So this goes here. Oh, didn't switch. It's not switching for me. There we go. I guess I got to do it like that. Well, there's our MOX nuclear fuel. That's the shape we want, and it'll autofill from there. So we have 9. I think, oh no, we have 21. That's what we wanted. We need 18, so we have more than we need. Cool. Now we'll put this together with some glass vials, some fuel rod cases. Let's see what this is called. Fuel rod empty is all it's called. These will go into the canning machine. We'll put this vial first, and this will take a few seconds. It's coming up on finishing, and there we are. We have our 18. It's going to do 3 more we don't need, but we'll leave it in there. That's fine. This gets combined together with some plates in the center of them. Actually, I have more plates here, so we'll take it from here and move it over here. Yep. So now we have our dual fuel rod made of MOX. We'll take that and let's go ahead. I'm excited about this. We're finally going to get some superpower. Before I do install them, I just want to show you what I've been dealing with for the past few weeks since I've installed this reactor upstairs. This is how much power we generate. We don't generate enough to run all the recyclers in the mass fab upstairs, nor to run this, which we've just installed. So the MFE, that's the reason why I removed the MFE from here. We really didn't need it. I thought we would have an over excess of EU power, but we didn't need it here, so I'm going to leave it here and just make some more MFSUs because now I will need it after we install this MOX fuel rod. But notice, it doesn't ever save enough. After we install this, my expectation is that it'll climb very high, so we will have an excess of power. Hopefully, my dreams won't get popped. Let's turn this off. We're going to change the frequency momentarily. And so now this is off, but we will be able to turn it back on with the lever. Cool. All right, so let's leave it off for a second. What I'm going to do is, these fuel rod of uranium I placed here just temporarily until, let's get rid of all these, until I got these MOX fuel rods up and ready to be implemented. So let's put these in here. And I can't shift click them in because they are not the same metadata. We need more room. I have another chest out here. Let me just put it out here, guys. Bear with me as I put this here. Zombird is dying outside. Okay, let's try this again. So we're going to go here. We're going to fill in all the spaces where it needs to go. But you know what? I'm going to do it a little bit different. What I'm going to do is just occupy one space here and turn it on, and the heat will be driven up. Now remember that the heat that I want, that I'm operating, is 75-75. I've moved it from 50 to 75. 75-75 heat. And that level is when this RF thermal monitor will shut off the reactor if it goes above that. So I don't want it hotter than this. So that's the heat that we want. We want something lower than that, actually. Maybe quite a bit lower. Maybe just 7,500. 75 away from our mark. So what I'm going to do is turn it on and have it heat up. Let's put it here instead. I don't know how this will be affected. I don't think it'll be affected. It doesn't have any durability bar, so I don't think it would be affected. But I'm going to leave it here, heat it up, and try to get up to 75. And I'll take a look at the info panel, make sure it's 75. I'll check between the two displays to see as close as I can get. I'll turn it off, and then I'll populate all the areas where they need to go, including the advanced heat vents. I'll replace them where they need to go. And then I'll turn it on, and it'll be stable. Hopefully. Cross your fingers. All right, so let's turn it on. Boom. All right, so we're generating about 20 EU per tick, but notice that the hotter it gets, the more EU you generate. And that's why we're trying to get this up to 75, because that's about as safe while being as hot as you can get, and generate the most amount of power without loss. In other words, it'll degrade at the same amount of pace or rate, whether it's super hot or cooled at 0%. So why not have it as hot as possible so that you can generate the most amount of power as possible? So we're waiting till we get up to 75 here. Okay, we're coming up close. We're at 74, and I'm going to shut it off as soon as it gets to 75. And it looks like we're there. Now, if I get close, I'll just sort of whimper my way in. You can see that it gets some damage. And that damage is not radiation. It's actually heat. You'll notice that there's no indication of radiation. Any blocks that are nearby can melt because of this. So it's a dangerous thing to get it up this high. And that's why we needed this much space around. This was done intentionally. So my suit will wear out after a while if I keep this up by taking these hits. That's why I'm not going to be there that close too long. Even though it's just rubber. It's easy enough to build another one. But yeah, I shut it off. We're at what appears to be 75, but this is inaccurate. It's not as accurate as I'd like it to be. So let's go over here to the info panel, and we can see that there should be a comma between the 7 and the 5. This is actually 7,536. This is fine. This is where I want it. Just not over 75-75 because our thermal monitor is set to that. So anything less than 75-75, and this will do. This is close enough. So you'll notice that we started off with a fuel rod that produces only 20 EU per tick. And now this single dual rod is now producing, I think it was 60 EU per tick before I shut it off. You can hit the reverse button or scan back, and you'll see what it was before I shut it off. But what I need to do now is put these back, and now we will fill all the MOX fuel rods where they need to go. And this should be easy enough to do, just like this. Now, the reason why it overheated or kept rising in heat is because we took out the advanced heat vents. Now that I've placed it back, the whole system, it's because of the pattern in which these things are placed, the whole system will be stable, and this should not rise anymore. Now, if for any reason one of these gives out where it overheats, then it will vanish. It'll just disappear. If that's the case, these guys next to them will have to work harder to cool off the system, but they will receive even more heat and die out quicker than this one did. And the chain reaction will spread out, and they will all be killed very quickly. And the only things remaining will be the heat rods. This will skyrocket to 100%, and kablooey, the whole thing will explode. Now in creative, I tested this out, and I want to thank you guys for telling me about this fuse glass. Turns out the fuse glass is more than just blast resistant, it's blast proof. I put the whole system, the whole reactor filled with MOX and turned it on, and it exploded in a fraction of a second, not even a second. Everything except for the glass remained. Even the reinforced stones just flew away. It wasn't a big enough blast to reach my island over there. And we have nowhere near as many MOX Fuel rods as I did in creative. So we are safe here. It did do some damage underground, but it doesn't matter. The water refilled it, and again, so it doesn't matter. But what I wanted to say is that watching this video, if I can tell you anything that'll help you, try to make your reactor room just this glass. And if you wanted to decorate it afterward outside with reinforced stone, go ahead. But this is what's really important and will protect you. Now, the chests haven't burnt up. I think they're fireproof. I don't know about the conduits, but everything seems to be holding up, and the lever as well, but that's going to be removed. We're going to go ahead and turn it on now and see what kind of power we're generating. I'm hoping for between 900 and 1100 EU. Oh, I forgot to turn on this. Boy, guys, I'm nervous. Here we go. Oh, I might as well just go for it. Oh, boy. Okay, minus. There we go. It's on. And we have 1044 EU per tick. This is awesome. Everything is stable and holding. Notice nothing is drying out. These bars on the heat vents would be going down, but they're holding just fine. Let's go check out the temperature out there. So we're at 7536 stable, putting out 1044 EU per tick. This is awesome. Let's go check out the MFSU. Remember, it couldn't keep up with anything. It is climbing. Awesome. All right, guys. Thank you for watching. If you have any suggestions for the next episode, please leave it in the comments. If you liked any part of this, please give it a thumbs up. And thanks for watching. I'll catch you all next time.